At the Center for Radiation Research at the National Bureau of Standards in Gaithersburg, Maryland, a search is underway. This search is going to be carried out by 3 scientists, Bob Schwartz, R.Schrack, and Tom Heaton. The search they are going to undertake is a search for the basic interaction of the fundamental building block of matter with another fundamental building block, the proton and the neutron. The proton we will illustrate as a red ball in a classical sense, as a round, hard sphere. The neutron we will illustrate as a black ball, also in the classical sense. Of course, they are really too small to be so illustrated. We are interested in the interaction of the moving neutron with the proton. Here, the LINAC generates a beam of electrons in the underground chambers. This beam is bent by a magnet system into a measurement room. There, at the end of the magnet system, a target is placed in order to produce neutrons. These neutrons then are allowed to go down a flight path where a detector is placed 40 meters away. The speed of the neutron can be determined by the time of flight from the point of creation to the other end. At one point in the flight path, a sample is placed. The selective absorption of this sample determines the interaction. Here we see the interaction of the neutron and the proton. It is attractive, and it is caused by the exchange of mesons. Both neutral, negative, and positive mesons are exchanged between the neutron and the proton. If this interaction takes place at a certain fixed range, we can think of the interaction as taking place in a box. Then only selective frequencies will be enhanced in this box, which will cause the interaction to have structure. We are now going to shoot a neutron past the proton and see its interaction. It is deflected. This deflection will be a monotonic function of the energy of the neutron if there is no selective interaction range. There is no structure in this interaction. However, there will be structure if there is a selected range. It is suggested by a paper published from Hungarian authors that this structure should be approximately 5% in amplitude. The cross-section is determined by measuring the transmission through a sample of polyethylene and one of carbon only. The carbon in the 2 samples is made to exactly cancel, so only the interaction of the protons is determined. Here, the polyethylene sample is carefully manufactured in the shops of the Bureau of Standards. Its thickness must be determined to within 1/1000th of an inch in order to completely cancel the effect of the carbon atoms. These samples are then carefully weighed. Here are the 2 samples used in the actual experiment, the carbon and polyethylene. They are then taken and placed in the sample holders that intercept the neutron beam. Here Mr. Heaton adjusts the sample holder that intercepts the neutron beam. Here you can see the polyethylene and carbon samples. In the rack, they will be placed selectively in the beam in order to interrupt the neutron path. Here a target is placed at the end of the LINAC electron beam flight path so that the focus of the electron beam can be observed. Here you can see the neutron producing target and the beginning of the flight path for the neutrons. Meanwhile, upstairs in the control room, the equipment is being checked. Mr. Heaton carefully checks all the parameters of the equipment, making sure their operating voltages are correctly determined. The success of the experiment depends upon the equipment operating over a long period of time in exactly identical conditions. Here at the end of the flight path is the detector. Equipment there must also be checked to determine if it is in proper operating condition, because this area is not accessible during the period of the experiment. Here's the LINAC itself. The electrons are accelerated down the LINAC and through this end into the magnet system. Here the magnet system deflects the electron beam into the various experimental rooms. The health physicist checks over his equipment. The LINAC operators set up The various components on this wall are the vacuum system and the magnet system controls. Here's the online computer that will actually gather the data. It must be carefully programmed and set up in order to take the data and record it in the manner desired. Here Dr. Schwartz adjusts the television monitoring system so that all conditions can be observed even though the experimental room may not be entered. Here the LINAC engineers make sure that their equipment is in readiness. The LINAC setup is begun. Beam has been obtained. The monitor here shows that we have acquired a beam of the desired intensity. We may now take data after we set the experimental equipment. This teletype allows us to observe the performance of the monitors. Here we see the oscilloscope presentation of the pulse, and here we see the scalers recording our incoming data. All this data is recorded on the computer for several hours to complete a single run. At the end of an experimental period, we again get ready to record our information on the teletype and on punched paper tape. Here, the output of the monitors and the number of neutrons and the counts from various detectors are recorded on paper. As well as on paper, they also come out on punched tape. Here, at the online computer, all the data comes out on punched tape, not only the monitors, but 4,096 channels of data of the neutron spectrum itself. At the completion of the punch out, the tape must be wound up on a reel. This part of our operation is not as highly mechanized as the other aspects. Highly skilled labor is here employed to wind up the 4,096 channels of data. When it is wound up completely, it is taken to the offline computer for checking to see if the paper punching operation has been completely successful. If the data recording operation is successful, it is accepted and read from the paper tape and placed on magnetic tape for use on a larger computer where it is analyzed and the cross-section obtained from the transmission data obtained in the experiment. Here is the theoretical cross-section, and here is our experimental result. Dr. Caswell observes no obvious structure in our data. However, further analysis must be made in order to ensure that the structure here reported in the Hungarian publication is not evident in any degree. Our initial reduction shows a deviation from the theory of a very small amount and of a very smooth nature. We fit this deviation with a polynomial that at all points is less than 1% from the currently accepted values. We then write a paper reporting our results, a search for structure in the NP scattering cross-section, which will be submitted to the same journal that published the Hungarian paper. Here is our experimental results. The dots are our data. That heavy curve is what they would expect. We see no evidence. The data indicates any structure anywhere near as large as indicated in their paper. And thus comes to an end a successful search, or rather an unsuccessful search in this particular case, for structure in the NP scattering cross-section.